So I think just the portrayal of more women in science is very helpful for young women to see, like, oh yeah, I can do that because she's doing that.
We're currently in the Stillwater Range. We're on the west side of the range in the volcanics.
And this site is somewhat unique in that it was the site of a gigantic super eruption. So, larger than any volcanic eruption we have recorded in human history. We've really never seen anything like this. So you think of Hawaii or Mount St. Helens. Those are involving less than a cubic kilometer of magma being erupted. This was 1,000 cubic kilometers of magma. Hundreds to thousands of cubic kilometers of magma are what super eruptions are. So, these are really unique events, and we've never experienced one before.
Basically what the system is this really strongly tilted extinct volcano.
You have a fault that essentially tilts the entire block, which is one of the cool parts of it because the volcanics are still attached to the frozen magma at this point, and everything's rotated over about 90 degrees, which we have that frozen magma chamber, which we're calling the Pluton, and then we have the volcanic rocks that are still attached to it, so we know which way was up.
The question is if the Pluton is actually related to the explosive erupted products. And so if the ages from the Pluton are overlapping with those volcanics, then that would tell you that it's likely that they were active at the same time. So we could be able to tie that magma chamber as the potential source for those volcanics, which is interesting because the source is really important in helping us understand why the eruption occurred or why it didn't.
It's like this puzzle that you're trying to figure out in geology. Your questions are like a very large puzzle, and you have only a few of the pieces to figure out what's going on.
And so when we're looking for rocks to actually pick up to study, ideally we want to take it from an outcrop, so from a piece of rock that's jutting out of the earth, instead of just a rock off the ground, so we know exactly where it came from.
So we're going to go around to those outcrops, basically just chisel out or hammer out a big chunk, which we'll take back to the lab and crush up and separate out the minerals that help us measure the ages.
We find this mineral called zircon, which is a geochronometer, which means it's a mineral that can help us tell time. So the age of the Pluton would overlap with the age of the volcanics for things that would be related.
When the magma erupts, it's really hot. It's like 750 degrees. When it hits the air, it's really cold, and that causes it to become a glass. And that glass has a composition, and we can analyze its composition.
Not every Pluton leads to an eruption, so there is also the possibility that it just kind of formed and then froze and no eruptions came out of it.
Hopefully some of the implications of this project gives us some insight into what can signal a small or a large eruption in other similar composition systems.
I feel like people think about geology and they're like, oh, you think about like someone with a rock hammer, like smashing at a rock. Yeah, that's kind of fun, but that's not where it ends.
Hard for me to kind of realize that, no, actually you don't have to be a genius to be a scientist. You just have to be excited about it, and then you just have to work hard to do it. So I think I would say to any young women who are interested in science that
if you find it interesting, it's worth trying, because there's enough people who want you to embrace that type of science, to get out in the field and try it with them, that even if it's hard for you, you're going to find people who are going to support you along the way.